Hi. So today we are going to discuss on trigonometric ratio, identities with examples. Okay. So first of all, let us discuss what is trigonometry. Trigonometry is the branch of mathematics that concern or deals with the specific function of angles and their application to calculations. In trigonometry, we study about the triangle, relation between its angles and sides. Okay, relation between sides and angles of a triangle. Okay. Then here our topic is trigonometric ratio. Then what do you mean by trigonometric ratio? What is trigonometric ratio? Then here for trigonometric ratio we discuss about the right angle triangle. This is a right angle triangle ABC. ABC. ABC is the right angle triangle and this is angle theta. Theta angle means this would be an acute angle. In a right angle triangle, if this is a right angle triangle, then in this triangle there are three angles and one angle is 90 degree and sum of other two angles that will be 90. If we take this angle theta, then this will be 90 minus theta and both the angles will be acute angle. Here, then the side just opposite to the acute angle that is known as perpendicular and thus just opposite to the right angle that is hypotenuse and the side on which angle forms that is base. Okay, let us consider perpendicular is denoted by b, hypotenuse is denoted by h and base is denoted by b. Okay, so how can we define ratios of the sides? How many ratio will be there? Then there are three sides, 1, 2 and 3, and we have to take two sides of these. Okay, then there will be way. How many ways can they be selected? Then there will be six ways. First, perpendicular upon hypotenuse, base upon hypotenuse, perpendicular upon base, base upon perpendicular, hypotenuse upon perpendicular, and hypotenuse upon base. These are the six ways uh, that denotes the trigonometric ratios. These are also known as trigonometric functions. Okay, and these trigonometric functions are sine, cosine, tangent, cotangent, secant, and coseconds. These are expressed. Sine abbreviation for SIN, that is cos, tan, cot, sec, and cosec. Okay, so we can say that trigonometric ratio or trigonometric functions are the ratio of sides of a right angle triangle with respect to an acute angle. This is an acute angle with respect to these angles. This angle, we if we take ratio of the sides, then that ratios are known as trigonometric ratios. Okay. Now here complete explanation of this trigonometric ratio. Sine is the ratio of perpendicular and hypotenuse, means sine theta equal to ab upon ac. Okay. Cosine is the ratio of base and hypotenuse and tangent is the ratio of perpendicular to the base, and cotangent, that is just reciprocal of this. We will discuss just base and perpendicular. Similarly, if we take secant, then secant is the ratio of hypotenuse to the base, and cosecant, that is hypotenuse to the perpendicular. Let us discuss in the next trigonometric ratio. Here is a triangle ABC and theta is an angle, and now we can say this is base, BC is base, AB is perpendicular, and AC is hypotenuse. Okay. Then first of all, if we take AB upon AC means sine theta. From definition of sine with respect to theta, from definition of sine we can say it is ratio of perpendicular to the hypotenuse. Then we can say that AB on AC. Okay. And if we talk about cos theta, then this will be base upon hypotenuse, and it will be equal to BC upon AC. Okay, now let us come to the tan theta, and from definition of tangent we can say that tangent is the ratio of perpendicular to the base, means this. Okay, and that will be AB upon BC. And cot theta is the ratio of base to the perpendicular, means base upon perpendicular, that will be BC upon AB. Okay, and next one is sec theta. Sec theta is the ratio of hypotenuse to the base. Okay, and that will be equal to hypotenuse is AC upon BC. Okay, and cosec theta, this is known as cosecant, and this is the ratio of hypotenuse to the perpendicular, means that will be AC upon AB. Okay, let us observe these six trigonometric ratios. This is first one, this is second one, this is third, this is fourth ratio, this is the fourth, fifth, and this is sixth ratio. Okay, now from first ratio we get perpendicular and hypotenuse. From first and sixth, from first and sixth we get, both are reciprocal of each other. Here we get sine theta AB upon AC, and this is AC upon AB. These are the reciprocal of each other. If they are reciprocal of each other, then we can say that sine theta equal to 1 upon cosec theta. Similarly, from ratio set, from this second equation and the equation number fifth, second and fifth, we get this one here, h upon b, and this is b upon h. These are reciprocal, means we can say that cos theta equal to 1 upon sec theta. And middle two, means third and fourth. If we talk about third and fourth, from third and fourth we can say that perpendicular upon base and base upon perpendicular, means tan theta equal to 1 upon cot theta. Okay, so let us discuss other trigonometric ratios and identities here, defining relation between tangent, cotangent, secant, cosecant in the term of sine theta. As we earlier studied that sine theta equal to 1 upon cosec theta, and cos theta equal to 1 upon sec theta. Okay, 1 upon sec theta. From these two equations, from these two, we can also say that cosec equal to 1 upon sine, and sine equal to 1 upon cosec, sec equal to 1 upon cos, or cos equal to 1 upon, like this, sec equal to 1 upon cos, cos equal to 1 upon sine. Okay, now we know that sine theta equal to perpendicular upon hypotenuse, and cos theta equal to base upon hypotenuse. Okay, in this, if we take ratio of sine and cos, then this will be cos theta, sine theta upon cos theta equal to P upon H whole upon B upon H. Okay, H will be cancelled with H, then we get P upon B, and from definition of tangent we get P upon B equal to tan theta, so we can say that tan theta. Okay, so sine theta upon cos theta equal to tan theta. This is this formula. Okay, and cot theta is the reciprocal of tan theta. Then we can say that tan theta, cot theta equal to 1 upon tan, and that will be cos upon sine. This is next one. Okay, now let us solve an example dependent on this. Then first of all, let us discuss about the Pythagoras theorem. Pythagoras theorem, which we study in the triangle chapter, and this says that in a right angle triangle, if this is a right angle triangle, this will be its base, this is hypotenuse, and this is perpendicular, and this is hypotenuse. In this, we can say that according to Pythagoras theorem, h square equal to p square plus b square. Okay, or b square plus b square c. From here we can calculate b square equal to h square minus b square. Okay, so there's given a question that in a right angle triangle, first of all, draw a right angle triangle ABC. This is a triangle ABC, right angle triangle. AB equal to 6. This one is 6 and 6 centimeter, and this one is 8 centimeter. Then we have to calculate this one. AC. AC is hypotenuse. Then hypotenuse square equal to 6 square. That will be 6 square plus 8 square equal to 36 plus 64 equal to 100. Okay, h square equal to 100, then h equal to, that will be 10 centimeter. Now we will find all the trigonometric ratio with respect to his given incomplete question, that is with respect to angle C. With respect to angle C, then we have to find out sine C. If we have to find out sine C, then that will be perpendicular will be 6 upon 10 equal to 3 upon 5. Okay, if we have to find cos C equal to, this will be base upon hypotenuse, and base upon hypotenuse, that will be 4 upon 10, sorry, 8 upon 10 equal to 4 upon, and tan theta, now we can solve it by using sides, or we can solve it by sine and cos. So there's like, we can say that sine theta upon cos theta. In value of sine theta, this is 3 upon 5, and cos theta, this is 4 upon 5. 5 cancel, this will be 3 upon 4. If tan theta is 3 upon 4, this implies that cot theta equal to 4 upon 3. It's reciprocal. Similarly, sec theta equal to 1 upon cos theta, and this will be 1 upon cos means 1 upon 4 upon 5 equal to 5 upon, and cosec theta, cosec is reciprocal of sine, then this will be 5 upon 3. Okay, this is for in a given triangle ABC. If two sides are given, then we can calculate third side by the Pythagoras theorem, and using Pythagoras theorem, when we find third side, now using trigonometric ratio, we can calculate all the trigonometric ratio, means sine, cos, tan, cot, secant, cos. Okay. Now, there is Pythagoras formula for trigonometric ratio. We can say that Pythagoras formula, Pythagorean formula. What is Pythagorean formula? In Pythagorean formula, that we can say that perpendicular square plus base square, that is hypotenuse square. Similar. Here we get sine square theta, cos square theta equal to 1. This is the first trigonometric identity. This is known as trigonometric identity. Identity. Then what is identity? Identity is an equation which is true for all the values. Means those equations which satisfy all value of the variable. A variable is theta. Then for every value of theta, it holds. Okay. Then first of all, let us derive this formula. Then we know that sine theta equal to p upon h, and cos theta equal to b upon h. Okay, squaring and adding, we will say that squaring and adding both the equation. Okay, we get sine square theta and plus cos square theta equal to p square upon h square plus b square upon h square. This will be p square plus b square upon h square, and from Pythagoras theorem we can say that p square plus b square equal to h square. Then h square upon h square cancel, this will be 1. Then we can say that sine square theta plus cos square theta equal to 1. We get the formula sine square theta plus cos square theta equal to 1. Okay, this is the first trigonometric identity. Now, to get another trigonometric identity, from here we can also say that sine square theta equal to 1 minus cos square theta, or cos square theta equal to 1 minus sine square theta. Transfer it. Cos will be transferred to the 1. right hand side, then that will be 1 minus cos square here side. Now from this we can say that this is the sine square theta equal to 1 minus cos square theta. Now divide it by cos square theta. If we divide it by cos square theta, then that will be sine square theta upon cos square theta equal to 1 upon cos square theta minus cos square theta upon cos square theta. Sin square theta upon cos square, this will be tan square theta equal to 1 upon cos square, that will be sec square theta minus cos square upon cos square 1. This can be also written as sec square theta equal to 1 plus tan square theta. This formula sec square theta equal to 1 plus tan square. Similarly, here is given that is cos square theta equal to 1 minus sin square. If we divide by sine, then we get this formula 1 plus cot square theta equal to cosec square theta. Okay, or we can say that cot square theta equal to cosec square theta minus 1. Okay, now sign up trigonometric ratio. If we draw a vertical line and an horizontal line, this forms a Cartesian plane. This forms a Cartesian plane, or we can say that this is the coordinate plane. And this coordinate plane divided into four parts, and these parts are first, second, third, and fourth. Each parts are known as quadrant. Okay, quadrant. Okay, this is the first quadrant, this is second, third, and fourth. Now angle, if we draw angle on this, then we get 0 degree here, and this will be 90 degree, this will be 180 degree, here 270 degree, 90 will be added to it, and finally if it completed one round, this becomes 360 degree. And 360 equal to 2 pi, and we have 90 degree equal to pi by 2, and 180 degree equal to pi, and this will be 3 pi by 2. Okay, 3 pi by 2. Now let us discuss the first quadrant. In first quadrant, all the trigonometric ratios are positive. If we draw an angle like this is a line, here an angle x. Now this is the perpendicular. Okay, if we find out trigonometric ratio, any trigonometric ratio, this will be perpendicular, this is hypotenuse, and this is the base. Any trigonometric ratio, in this case we get like this is in right hand side, and this is upward to the x-axis, and both the value p upon b, p upon h upon b, all the values that will be positive. So we can say that in this quadrant all trigonometric ratio that are positive. Okay, now let us come to the second quadrant. If we come to the second quadrant like this, okay, if we come to the second quadrant, in this case this will be angle, this is the angle, and in this angle if we get here, this is the perpendicular and this is the base. Okay, perpendicular base means this is p, this is b. Here p is positive, p is positive and b is negative. Okay, means the formula which contain b, that will be negative, means only sine equal to p upon h, and cos equal to b, sorry, cosec equal to h upon p. These two ratios will be positive and all the ratios will be negative, means sine and its reciprocal cosec, they will be positive. Okay, in third quadrant both will be negative, means if both will be negative, means p and b both are negative, then p upon b, that will be cancelled, means here tan theta and cot theta, these will be positive, and except than these, all the trigonometric ratios will be negative. Okay, and now let us come to the fourth quadrant like this. This is the angle x. Okay, if this is the angle x, then this will be perpendicular for it. Here we get this perpendicular p is negative. P is negative, B is positive. Okay, if perpendicular is negative, P is positive. In this case, we can say that the trigonometric ratio which contain P, that will be negative, and which contain B, that is positive. Means those will contain like sine, cosec, tangent, and cotangent. They will contain negative sign, and only cos and reciprocal of this. These two ratios will be positive. Means in first quadrant, sine and its reciprocal cosec, they will be positive. In second quadrant, sorry, in first quadrant, all the trigonometric ratios. In second quadrant, sine and its reciprocal cosec. In third quadrant, tan and its reciprocal cot. In this quadrant, cos and its reciprocal sec. And these trigonometric ratios will be positive. Okay. Okay.